Whenever you go to a stationery shop, you see that things are kept in a very systematic manner. All notebooks on one side, all pens on one side, and even amongst pens, all similar colored pens are stacked together. Why is it so? Because this systematic arrangement makes it very convenient for the shopkeeper to find the particular item and give it to the customers. Something like this was required years back. In the beginning, scientists studied the properties of individual elements. But as the number of elements being discovered started to increase, so did their properties and study. It became a really hectic process to study the elements separately. So they started thinking of ways to group the elements in such a manner that elements belonging to a particular group could have the same properties so that they do not have to study the elements separately. A scientist then came up with a way. He classified the elements as metals and non-metals. This was the first broad classification of elements. But one day, confusion arose. Some elements show both metallic and non-metallic characteristics. So should these elements be placed under metals or non-metals? Hence, this system failed. They then came up with different properties like melting point and boiling point to classify the elements. But the problem with these properties is that they change with different conditions. They do not remain constant. Hence, they wanted some property which would remain constant under any given condition. Yes, atomic mass of an element. The atomic mass of every element remains constant under any given condition. One such scientist who was aware of the concept of atomic mass was J.W. Dubinier. He had also studied some elements belonging to the same family. Let's see what his family of elements were. He observed the three elements calcium, strontium, barium. The three of them were metals and they showed the same appearance and reactions. So according to him, these three elements belong to the same family. Further, he observed that when he placed these three elements in increasing order of atomic mass, he observed when he took the average of the first and the third element, he got 88.5. which was nearly equal to the atomic mass of strontium. He repeated this for another family of elements, chlorine, bromine, iodine. The three of them are non-metals and they show the same appearance and reactions. He continued the process for these three as well. He arranged them in increasing order of atomic mass and found the mean of the first and the third element. It came out to be equal to 81.25, which was nearly equal to the atomic mass of bromine. Based on these observations, Dubinier gave the law of triads, according to which when three elements belonging to a triad are arranged in increasing order of atomic mass, the average of the first and the third element give the atomic mass of the middle element. But there was some problem with this law of triads. By the time Dubinier gave his law, 30 elements had been discovered. But his law was valid for only 3 triads, that is, for only 9 elements. It failed to arrange the remaining elements. Another problem with his law was it was not applicable in the same family. We have seen that a family of elements, chlorine, bromine, iodine, when placed in increasing order of atomic mass, they follow the law of triads, as the average is equal to the average mass of bromine. So the average comes out to be nearly equal to the atomic mass of bromine. So for these 3 elements, the law of triads is valid. He repeated this for another member of the family. Fluorine belongs to the same family of elements. The 3 of them are non-metals and they show the same appearance and reactions. He continued the process. He arranged them in increasing order of atomic mass, took the average of the first and the third element. It came out to be equal to 49.5. which was not equal to the atomic mass of chlorine. Hence, his law, the Dubinier's law of triads, failed. Alright. So X, Y and Z are the elements of a Dobinier's triads. If the atomic mass of X is 7 and that of Z is 43, the atomic mass of Y should be? Well, the Dobinier's law of triad states that when three elements belonging to a triad are arranged in increasing order of atomic masses, the average of the first and the third element. So in this case, the average comes out to be 25. So the average of the atomic mass of the first and the third element is equal to the atomic mass of the middle element. So the atomic mass of Y should be 25. Another scientist, John Newland, he was aware of Dobinier's work. Newland was also a music lover. He observed that the notes of music repeat after a certain interval. So do, re, mi, fa, sol, la, ti, after the seventh note, that is after ti, the notes repeat. It's again do, re, mi, fa, sol, la, ti. At the same time, he had in his mind the Dobinier's work, his work on triads. So like in Indian music, the notes sa, re, ga, ma, pa, dha, ni, they repeat after the seventh note. It's again sa, re, ga, ma, pa, dha, ni. Similarly, in case of Western music, the notes repeat after the seventh note. So when Newland arranged the elements in increasing order of atomic mass, he observed that after the seventh element, the properties of the elements start repeating. So every eighth element starting from the given element shows the same properties. So in this case, beryllium, magnesium, calcium, they all show the same properties. Lithium, sodium, potassium, they show the same properties, and so is true for all the elements. So after the seventh element, that is, every eighth element shows the same properties starting from any given element. So based on this observation, Newland gave his law of octaves. Octa means 8. So every eighth element shows the same properties as the starting element. This was the first time that periodicity was observed during the classification of elements. Periodicity means repetition of properties after a certain interval. So like in the Newland's law of octaves, the properties of the eighth element are the same as the starting element. So this was a very important feature that was observed in his law of octaves. He was awarded the Davy Medal for his contributions to the classification of elements. There was some problem in the law of octaves due to which it is not accepted today. What was it? By the time Newland gave his law, 56 elements had been discovered. When he placed the elements after calcium in increasing order of atomic mass, he observed that the properties of chromium were not similar to that of aluminium, properties of titanium not similar to silicon, and so on. So after calcium, the law of octaves, that is the properties of the 8 elements repeating after the starting element, failed. So these elements do not show the same properties as the starting element. So all the remaining elements after calcium fail to be accommodated in the Newland's law of octaves. Hence, the law of octaves is discarded. Although Dobinier's law and Newland's law are discarded today, they are not accepted, but they went a long way to form the periodic table as we know today, because properties like atomic mass and periodicity given by these scientists form a basis of the modern periodic table. Hence, these are very important.